So this is the final review, number 15. You'll notice here we are going to take f of x and subtract g of x. Make sure that you write that out. F of x is 3x cubed minus 5x squared plus 7x minus 11. So there's your entire f of x. Now we're going to do minus the g of x. G of x is 8x cubed plus 15x squared minus 9x minus 21. Careful here because you have to distribute the negative through. So we're going to end up with 3x cubed minus 5x squared plus 7x minus 11. But then we have minus 8x cubed minus 15x squared plus 9x and then plus 21. Your goal now is to combine all like terms. You've got a 3x cubed and a negative 8x cubed. That's going to be negative 5x cubed. Then we have x squared. That's going to be minus 20x squared. We have 7x and 9x. That's going to be 16x. And finally, we have a negative 11 and a 21. So that's going to be plus 10. Easy? All right. Moving along, solve this. All right. We've got to make sure that you get this portion of the equation alone first. Whatever is e raised to the exponent, get it alone first. So we've got to take that 22 and subtract it on each side. 150 minus 22 is going to be 128. Okay, now you have to be really careful. When you have an exponent that's a fraction, you're going to have to raise both sides to its reciprocal. So we're going to raise this side to the 3/7, this side to the 3/7. And when you have a power raised to a power, you multiply it, but you're multiplying reciprocal, so that becomes 1. We have 3x plus 5 raised to the first, so we're done there, is equal to 128 raised to the 3/7. Careful here. I rewrite this as, how about 3x plus 5 is equal to 128 to the 3/7. That's like the seventh root of 128, but then cubed. Is 128 a perfect seventh root? How would you get there? 2. Good. So 3x plus 5 to the seventh root of that is going to be 2, but then cubed. All right. I've got 3x plus 5 is equal to 8 minus 5 on each side. And 3x is equal to 3. Divide x equals 1. Okay, x equals 1. Keep in mind, I'm going fast. Revisit this tonight on YouTube. Next problem, find all the solutions to this equation. All right. Remember, you try to factor this by grouping, but factor by grouping will not work at all. What you're going to have to do is the p over q. You have the p over q. Okay, back p is the factors of the constant. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4 divided to 30, plus or minus 5, plus or minus 6, plus or minus, what comes next? Plus or minus 10. And then we've got plus or minus, how about 15? And then plus or minus 30. This is all going to be divided by, now Q is the 2. It's the leading coefficient. So plus or minus 1, plus or minus 2. Now, I advise you, yes.
What is the P factor?
P is the are factors of that 30, factors of the constant. The Q are factors of the leading coefficient. Correct. Yes, that has an X really. It's just X to the 0. All right, now you're going to go ahead and you're going to use synthetic division. And you're probably going to go through and you're going to test. You're going to test probably a 1, maybe a negative 1, then maybe move into the 2s, test a 2, test a negative 2. That's the order in which I would test them. Okay? Now, did you see which one was going to work here? Take a look. Which one will work? So you don't have to waste time. A 2 will work. Let's go through that. All right, I'm going to test the 2. This is synthetic division again. And we have to write our coefficients of the polynomial. So we have 2, then negative 3, then negative 17, and 30. We bring down 2, multiply 4, add 1, multiply 2, add negative 15, and then this is going to be negative 30. Remember, that 0 is called the remainder. Since it is a remainder, then it divides into it nicely, and what you have left right here is 2x squared plus x minus 15. It's a quadratic. Set that equal to 0 because we're trying to find roots. Okay, and now what we can do is try to factor this. All right, so 2x and x, we factor that. What do you think? X plus 3, and then what? Minus 5. Is that going to work? We've got a negative 5x and a positive 6x. That's absolutely going to work. Zero product property. We have, we're going to end up with x is equal to a positive 5x. And then x also equals negative 3. Okay. Now, careful. What else did we find as a 0? 2. So x is also equal to 2. Yes. We just used the Q. The Q was the ratios of the leading coefficient. You have to write out the entire thing, but we did have 1 over 1 is 1. 1 over 2 is 1/2. That kind of deal. You remember? Okay, I'm just kind of saving time right now. It's on x equals 2. How did I pick 2? Oh, you see it, it's from the synthetic division. That's also a 0, please. Next problem. Find all the solutions to this. Right. X to the 4th minus 81 equals 0. Well, there are two ways to do this. We could factor squares. Or you could just add the 81 to each side. Is 81 a perfect 4th root? Okay, let's see. Plus 81. Plus 81. We end up with x to the 4th is equal to 81. When we take the 4th root sure that index is 4 there. We have x is equal to 4th root of 81. 3. Should it be plus or minus? Yes. Questions at all about that? Yes. Yes. So if I were to go through this other way, I could break it down to x squared minus 9, and then times x squared plus 9 is equal to 0. That's because x to the 4th minus 81 is the difference of perfect squares, which turns into a sum of difference. Here, okay, I'm going to have x, well, this is another perfect, difference of perfect square, so it's x plus 3, x minus 3. This one is just x squared plus 9. You're going to get, when you use the zero product property here, you're going to get x is equal to a negative 3, x is equal to a positive 3. Then when I said this one, x squared plus 9 equals to 0, guess what happens? You can't take the square root of a negative because we're going to subtract 9 on both sides. We end up with x squared equals negative 9, and you can't take the square root of negative and end up with a 0. Does that make sense? Moving ahead. Number 19. What is one solution to this equation? Okay. So I would try to factor it. If it's not factorable, then we can go to the quadratic formula. So first try to factor. Then we can try the quadratic formula if that doesn't work. Okay, factor. How about we go 3x and x? Any ideas? Plus 4 plus 1? Right. So let's go, we know this is 4x. It's going to be the 3x for the outer. Gives me 7x. Checks out. Great. And now we have two solutions here. When we use the zero product property, either 3x plus 4 is equal to 0, or x plus 1 is equal to 0. This yields x is equal to negative 4/3. This one yields x is equal to negative 1. Easier one. Okay? Moving ahead. Graphing. You have to be able to graph, folks. Okay? Now, for this particular problem, I want you to pay attention to what I'm not going to use here. I'm not going to use this at all because I don't want to use the parent function for this. What I would like to find out is what x cannot equal, so find some vertical asymptotes. Now, vertical asymptotes are where x cannot equal. So we set the denominator, x plus 2 equals 0 and solve. So it's going to be x equals negative 2. We've got a vertical asymptote. That vertical asymptote will be right here. Equals negative 2. We also have a horizontal asymptote. Any ideas? It's down 3, right? So it's going down 3. Okay. Now the key is just to plug in one number to the right of the vertical asymptote and one number to the left, and let's see what happens. So this is going to be y is equal to, how about we plug in a negative 1, see what happens. Okay. Let's go y equals 4, all divided by negative 1 plus 2, and then minus 3. Simplify this to be 4 over 1, so it's just going to be 4 minus 3 is 1. Do you agree with that? I hope so. We have a point here of negative 1, comma 1, input output. Plot that, negative 1, 1. We also could plug in, how about a negative 3? Y equals 4 all over, negative 3 plus 2, and then minus 3. It's going to be 4 over negative 1, which is negative 4 minus 3, negative 7. So we're going to plot this point, which is negative 3, comma, negative 7. Remember, I'm not using the parent, so I'm not starting at an imaginary start. I'm starting right from the origin. All right, negative 3, negative 7, 2, 3, 4, 5, 6, 7. This only type of graph that you're going to have to be worried about when not using a parent function. Do you get me that now? This is the only one you're going to have to worry about when not using a parent. You have to find vertical asymptote, and you have to find a horizontal asymptote. After that, you are good to go. Vertical asymptote, horizontal asymptote. How do you know to find a vertical and horizontal asymptote? Because we have a fraction. And there are always restrictions on fractions. The denominator never equals 0. What would produce a 0? Well, that was a negative 2 right there. You can't have that happen. Does that make sense? Horizontal asymptote. Remember, if this were not here, it would be 0. But then since this is down 3, it will be down 3. The horizontal asymptote will move down 3. Not really. Not. Okay. Moving ahead. Now we have to graph a log. And all of these graphs are going to be compared. Remember our 4 columns here? Well, for the most part, you're not going to have to worry about horizontal stretch factors and vertical stretch factors. Maybe a vertical stretch factor. All right. Log base 3 of x minus 6 plus 2. Well, what we have to do is we have to find out what the parent is. The parent is just y equals log base 3 of x. Write this in exponential form. Remember, let's find element. Base 3 raised to the y is equal to x. This is the only time that you substitute into y for logarithms. All we do is substitute 0. What's 3 to the 0, folks? 1. 3 to the 1? 3. 3 to the negative 1? 1/3. We have an HK, which is our 6, comma 2. And remember, you can put an x there at the imaginary start point. It's not a part of the graph at all. 6, comma 2 is going to be your 6 of 2. I'll put an x right there. Do you remember what goes through the 6, 2? Not a horizontal asymptote, but a vertical asymptote. For logarithms, it's a vertical asymptote. Now, what we can do is look at this and think, does it have a vertical stretch factor at all? Is there a number out here? No. Don't worry about it. Is there a horizontal stretch factor? So is there a number right here? No. Don't worry about it. So we're going to graph those points from the imaginary start point, the x that you're going to put on there tomorrow. So 1, 0. 3, 1. 1, 2, 3, 1. And 1/3 negative 1. Does that make sense? You need that vertical asymptote. You need those 3 points, okay? And then trace that graph with arrows on both ends. Domain and range. Let's make sure we know how to do domain and range here. First, the domain. X has to be greater than 6. And it's not greater than or equal to. So you can't touch that asymptote. Now for the range is the easiest for logarithms because it's going to keep going up and come down and continue to reach all y values that are negatives. So y is equal to all the others. There's your graph of the logarithm. Going back, sorry. Graphing this. This is an exponential function. Now, just down a bit. Remember, we can use parents for all of these, except for the fraction ones. Right? This one here, parent is y equals 3 raised to the x. Don't convert this one, it's not a logarithm. All you're going to do is plug in. Should we plug into the y's or the x's, folks? X is the only time you plug into the y's is when you are graphing logarithms. Good. 0, 1, and negative 1. Plug in 0. Well, 3 raised to the 0, 1. 3 raised to the first, 3. 3 raised to the negative 1 is going to be 1/3. Now we do have an HK here. The HK is going to be 2 comma negative 4. Remember, let's put an X at that HK. 2 negative 4. Now, since this is an exponential function, what kind of asymptote does it have? Anyone know? Horizontal. Guys, logarithms and exponentials are inverses of one another. So a logarithm is a vertical asymptote, and an exponential is a horizontal asymptote. Now all we have to do, 0 comma 1, 1 comma 3, and then negative 1, 1/3. Negative 1, 1/3. Draw this through an approach. Go up exponential. There's your graph. Okay, for the domain, x. Well, x can be all real numbers there. It's going to continue to the left and continue to the right. The range. The range is going to be, well, y has to be greater than negative 4. Right, perfect. There's your graph of that exponential. Number 23. Okay, we have to simplify this. That means we can get common denominators. Right. The least common denominator would be 2 times x plus 5. So I multiply this side by 2 over 2. Then I multiply the right-hand term by this x plus 5 over x plus 5. This is going to give me one large fraction with 2 times x plus 5 in the denominator. There's my common denominator. Then what I'm going to do is I'm going to distribute. I've got 2x minus 8. This is going to be plus 3x squared, and then plus 15x. Try to simplify. How about we start with 3x squared, largest degree. 15x and 2x plus 17x. And then we have minus 8, all divided by 2 times the quantity x plus 5. Did anyone go through and try to factor that and see if it was simplified? Anyone at all? Yeah, I believe it's going to be simplified. You could do 2x plus 10, but keep in mind, at the end of these, you want to make sure that nothing is going to create one factor form. There's going to be multiple choices. You want to choose which one. So, we go either way, all right? Next problem. Graph the following one's going to be a little difficult. You got to remember some things here. For this particular problem, I see 4 terms. I could do the whole P over Q thing, but and it would work. P over Q would work. However, I'm going to try to factor by grouping because I see 4 terms. Got to recognize that. Now I taught you to group the first 2 terms together. If it's a minus, put a plus and negative. That will prevent errors. Now let's factor out. No, that wouldn't make any sense of changing the problem. You don't want to distribute anything. That, with what I did up there, is to change just subtracting 16 and adding a negative. It's the same exact problem. Just helps with your grouping. I'm going to factor out an x squared, so I'm going to get x minus 3. Now I'm going to factor out a negative 16, and we're going to end up with x, and then minus 3. Doesn't that make perfect sense there? And what you'll notice is we have an x minus 3 and an x minus 3 that we can now factor out, which becomes y is equal to x minus 3, okay, that's factored out. And look what's left. It's x squared minus 16. Zero product property. So what we can do is take this y and set it equal to 0. So we have 0 is equal to x minus 3. This is a difference of perfect squares, so it's x plus 4, x minus 4. And zero product property, set them all individually equal to 0. We've got x equals 3. X equals plus or minus 4. You have 3 solutions there. Make sense? I'm going fast, but hopefully it's still making sense. Yes? Sorry. Oh, we've got to graph this. Sorry. All right, if I'm going to graph this, this is important. I'm going to graph this. I'm going to put points at 3, positive 4, and negative. So here's 3. Here's positive 4. Here's a negative 4. Are any of these double roots? You remember what a double root is? If it were this, if it were x minus 3 squared equals 0, that you left off, this would be considered a double root because you get x equals 3 twice. So it's not, we don't have any double roots, so there's no bouncing. Now we have to look at our original equation. The degree is odd. Remember, he's standing at odd positions. And the leading coefficient is positive. This one here, up to the right or down to the right? Up to the right. So you know that this thing is going to be going up to the right. Should it go through or bounce here? That 4. It should not bounce, right? It's not a double root. It's going to go through, but it's got to come back up and go through. And then go back down. Remember, am I concerned how low you're going to go here or how high right now? Not at all. Makes sense? There's the graph of that polynomial function. Because it has an odd degree. That's an odd degree. And that is a positive 1, so it has a positive leading coefficient. You might want to look that up in your book. Why did I circle that? Because I'm telling you that you don't have to go too high here. I'm not concerned with how high you're going. This might be a multiple choice for you to match. Doesn't matter how high you can go right now. Really, you're looking for the roots. Okay, and this is not a part of the problem. It's just showing you what a double root is. There are 15 runners in a cross-country race. How many ways can the first, second, and third place medals? Well, you have to be careful. Order matters when you're racing. There are all kinds of different ways. Well, the first place. First, how many different runners could actually finish first? 15. For second, how many runners? place, there could be 13. This is the same thing as 15 permutation 3, which is 15 factorial all over 15 minus 3 factorial. And this could be 15 times 14, and then multiply by 13. We're going to end up with 2,730 different ways that we could award the first 3 places in the race. Okay, moving ahead. Yes. 24. 26 says, at your favorite restaurant, the menu has 6 appetizers, 4 main courses, and 3 desserts. How many different ways can you order 1 appetizer, 1 main course, 1 dessert? These are 3 points tomorrow. For the main course, for appetizers, do a 6 to choose from, multiply by 4 main course possibilities, then multiply by 3 desserts. It's going to be 24 times 3 is going to be 72. 72 possibilities for your order. This is the fundamental accounting principle. Moving ahead, 27. In a bag there are 21 $20 bills and 11 $100 bills. You are to choose 2 bills without replacement from the bag. What is the probability that the first bill you choose will be a 20 and the second bill will be a $100 bill? All right. So the first draw. First time you reach into this bag here, let's see what's the probability the first bill you will choose will be a 20. How many 20s are there? 21. There are 21 out of how many bills altogether? 32. Very good. Now keep in mind it says here that we are we going to be replacing it? No, we're not going to replace it. It says without replacement. We're not putting the first bill back in. So now we're going to get to the second draw. We want to know what's the probability of choosing a $100 bill. Well, how many hundreds are there? There are 11. But now, how many bills were in there? 31 to choose from. If you want to know the probability of these, you better not add them. We're going to multiply them. They're dependent events. Multiplying these together, we're going to get the following. It's going to be 21 divided by 32, all multiplied by 11, and then 31. We're going to get 0.233. And that is 23.3%. There's your probability. Questions at all? Okay, moving ahead. Given f of x, x minus 5, and g of x squared minus 2x plus 5. Okay, now we're finding the composition. For this particular, right here, are we putting g into f or f into g? F into g. Yes, f is inside of g there. So first, I'm going to write the g out, but in place of every one of the x, I'm going to write large parentheses. So we have x squared minus 2 times x plus 7. Now keep in mind what we're going to do here. We're going to put f inside there, f of x. Then we're going to put f of x inside there as well. So what's going to go inside here? X minus 5 here. X minus 5. This is the entire g of f of x. Right now, g of f of x is equal to, we're going to simplify this. We're squaring a binomial. It's going to be x squared minus 10x plus 25. Distribute minus 2x plus 10 plus 7. So we 3x squared. Let's combine some like terms here, minus 12x. And then 25 and 10 is 35, and 7 is going to be 42. Does that make sense, guys? You just found the composition. Students, I've seen a common mistake of putting G into F. You have to make sure that the inside F will go into G in this problem. Moving ahead, 29, find all the solutions. Here is where tons of mistakes are made. You have to make sure you know your logarithm. You have to. All right? It says find all the solutions to this equation here. Well, you have to be careful. In log form, this is going to be log. We have a base of 2. An answer of x minus 4 is equal to 6. It's going to be rewritten. Base is 2. Raised to the exponent is 6. And that's going to be equal to the answer. The answer is x minus 4. Now, shift to this 6. Anyone know that offhand? 64. Very good. So I'm breaking this down. It's going to be 64 is equal to x minus 4. Add 4 to each side. 68 is equal to x. Any questions about that at all? Right, moving ahead with more logarithms. Find all the solutions of this equation. I can't stress enough. If you don't know these log properties, you're going to get several problems wrong. Since we are adding, and you know a logarithm is an exponent. We focused on that for many, many weeks. A logarithm is an exponent. When you add exponents, what are you going to do, really? You're multiplying. So, what we have here is log base 4 of negative x times x plus 10 is equal to 2. This over to the side here. Now, what I can start to do is use that whole starting process from log form to exponential form. So I've got a base of 4 raised to an exponent of 2 is equal to, I'm going to distribute all in one step here, negative x squared minus 10x. This 4 squared is 16, so if I subtract 16 on both sides, I end up with 0 is equal to negative x squared minus 10x minus 16. Now, because I have a negative out front, there is just a simple way to get rid of those negatives. Multiply through by a negative 1. Multiply through by negative 1, the entire thing. You'll end up with 0 is equal to x squared plus 10x plus 16. We can go ahead and solve this. Let's see the exact rule. Good, 10x. So how about we could try a 4 and 4? That won't work. We could try an 8 and a 2. 8 and a 2, both are positive. Zero product property. X is equal to negative 8 and x is equal to negative 2. Now always check for extraneous with these. Always check for extraneous. So take a look. Go to the entire page. When I plug in a negative 2 or a negative 8, does that produce a negative when you're taking a log of it? No, it does not. Both of these are going to be answers. Negative 8 and negative 2. Go ahead. 4 squared. 4 squared. Log base answer exponent. Right? Moving ahead. Okay, number 31. Simplify this. Okay, again, what we can do here is maybe break down the 64. raised to the x. I'm going to let this equal something for a moment. I'm going to just let it equal 1. Right. Let's try to simplify. Let's see if we can simplify it y. This 2 is going to be your base. This y is going to be your exponent. And this 64 over x is going to be your answer. So as a base of 2 raised to the y is equal to 64 raised to the x. Some of you are looking at the strings, but you've got to remember your log form going back and forth. Now, what I can do is try to simplify 64. Can we rewrite 64 with a base of 2? 2 raised to the what? 6. Excellent. 2 raised to the 6. All right, so we've got 2 raised to the y is equal to 2 raised to the 6, but then raised to the x. When you raise a power or an exponent to another exponent, what do you do with those? You multiply them, right? So right now I'm going to have the following. I'm going to have 2 to the y is equal to 2 to the 6x. Well, guess what y has to equal then, guys? 6x. Y is equal to 6x. But we set this entire thing equal to y, so guess what it simplifies to? The entire thing. What's your final simplified form? Just 6x. You set this entire thing equal to y, and now that's what it equals, 6x. So your simplified form, 6x. Moving ahead. All right, we need to simplify this now. Okay, there's some tricks here. Log base 3 of 1 over 81. Right. So log base 3 of 1 over 81. I'm going to set equal to something. Just let's see what we do. How about just y? That means base of 3 raised to the exponent of y is equal to 1 over 81. There are a couple ways to do this. It's not the only way. Is 81 a perfect cube? Is 81 a perfect cube? 3 to the what gives you 81? 3 to the 4th? All right, well, check this out. Let's go 3 to the y is equal to 1 all over 3 to the 4th. How can I somehow write this side here without a fraction? 3 raised to the negative 4th. Nice job, yes. So I've got on this left side, 3 to the y is equal to 3 to the negative 4th. Guess what y is equal to now? Y is equal to negative 4. And I know this is fast, folks, but again, you can keep on replaying this. 33. Solving this. This is a long problem, but you're going to have to do something like it. But this should be one of the problems I see the best results on. If you have a big equation like this, you want to get rid of fractions. Get rid of fractions. So you're going to multiply everything by the LCD. I'm going to surround it with grouping symbols. And what I want to point out and make sure that you understand is that 4x squared over there, minus 1, that's the difference of perfect squares. It's really equal to 2x plus 1 and 2x minus 1. Okay? Keep that in mind throughout this. So I'm going to multiply through by, just so that everyone can see it, 2x plus 1 and 2x minus 1. When I distribute that entire thing, the 2x minus 1s cancel, and you end up with x multiplied by 2x plus 1. Are you okay with that? Now, bring down the minus, and 2x plus 1s here will now cancel. We end up with minus 2 times 2x minus 1. Since 4x squared minus 1, this one, is equal to 2x plus 1 times 2x minus 1, the entire thing is gone. We just end up with x squared plus 20. Now it becomes an algebra 1 problem. You're simplifying, distributing. Here we go. Distributing 2x squared plus x. Distributing minus 4x plus 2 is equal to x squared plus 20. And now what I have, I'm going to get one side equal to 0. Let's start to move some things around. How about subtract x squared, subtract 1. Subtract x squared, subtract 1. I have x squared, and a positive x and a negative 4x. That's going to be minus 3x. Minus 18 equals 0. Does this factor nicely? Better factor nicely. We have an x and an x. How about a negative 6 and a positive 3? We end up with, after you use the zero product property, x equals negative 3 and x equals 6. Here are your solutions. Moving ahead. Find the quotient. Guys, when you divide by fractions, you're really multiplying by the reciprocal. So I'm going to take, we got x squared. You know what, the key, before I even do this problem, is try to write it in factored form first. You're going to notice a bunch of things are going to cancel nice and create ones. So I'm going to try to factor this. How about 9 and 3? A negative 9 minus 9 and a positive 3. Does that work? Should. Now, for this denominator here, how do I factor out the GCF? Always factor the GCF. So I'm going to factor 2x out, and that's going to leave x plus 1. This is going to be multiplied by, so we're going to take the reciprocal of this. The x squared is the numerator. Now, the denominator, you might want to factor in x and x. What do you think? 9 and 5. So how about a minus 9 and a minus 5? Does that work? Since we're multiplying now, we can create ones. Notice x minus 9, x minus 9. Let's see what else. Do you see anything else? Yes. Should. X and one of these x's, so this is now raised to the first. Now simplify it all. This will be x left over here, x times x plus 3, all divided by x plus 1, and then x minus 5. I wanted 2, sorry. I forgot the 2. That would be simplified. Easier what? No, don't multiply it through. You should be all set. Let's say it's basically multiply through. Then you're going to have 35. Find this product. Again, this is just a factoring problem. Let's factor. Factoring is numerated. X. X. 32. How about 84? Now in the denominator, right here, let's pull out a GCF. GCF looks like it's going to be 6. This is going to leave x plus 7. Do we have to reciprocate it all? No, it's already multiplying. So it's multiplying by x squared minus 49 is always easy to work with because it's a difference of perfect squares. In the denominator, we have, I'm going to pull out the x. x plus 4. Now to cancel t. Let's go with x plus 4, x plus 4, x plus 7, x plus 7. You see anything else? Anything? I don't. We end up with x plus 8 times x minus 7, all divided by 6 times x. And moving ahead, find f of negative 2. When you're doing something like this, these are truly 3 points, so to ensure that you do it correctly, you substitute inside of parentheses. Alright, f of negative 2. My advice to rewrite this in place of every x right parentheses. Inside those parentheses, substitute your x down. This is going to end up being 4 plus 10 minus 8, all divided by 7 multiplied by 4. 4 and 10 is 14, minus 8 is going to be 6. All over. 28, should I leave it like that? No, let's simplify. How about we just cut it in half? So 6 divided by 2 is 3. 28 divided by 2 is 14. Will that work? Yes. Okay, moving on. Now I've added some. Those of you who printed it out, these are all graphs. I would pay attention, write them down, know that it's recorded. Okay? Let's begin. 37, we're graphing is quadratic. I'm going to do the top one. I have one for you to try down on the bottom. So watch. Can I use a parent for this? Yes, it's a quadratic. It's in transformational form. HK. What's HK up there? 2 negative 5. All right, 2 negative 5. We can put an X there if you want. 2 negative 5. And note, be careful here because that's actually going to be a point. What shape is this going to be? For Outlook, it's a quadratic, folks. So, now, let's come up with a parent. You know the parent for a quadratic is just x squared equals x squared. Alright, now, if we plug in 0, we're going to get 0. 0 squared is 0. Let's plug in 1. 1 squared, 1. 2 squared, 4. Negative 1 squared, 1. Negative 2 all squared, 4. Is there a vertical stretch factor? Yes, there is. It is negative 3. So be careful here. It's equal to negative 3. That negative 3 doesn't affect the x or the y's. The y's. So negative 3 times 0 is 0. Negative 3 times 1 is negative 3. Negative 3 times 4 is negative 12. Negative 3 times 1, negative 3. Negative 3 times 4, negative 12. There is a vertical stretch factor of negative 3. Right here. Affects the y's. Now, all we have to do is plot these points from your HK. So we're going to plot these. Since we have a negative 12, we probably won't be able to use those, but we'll do our best here. Okay? So from this HK, we're going to go 0, 0. We stay there, so that's going to be the vertex of my parabola. Then we're going to go right 1, left down 3. Right 1, down 3. Then we're going to go 2 to the right, and down 12. We're going to be off the grid, so we'll simply say left 1, down 3. Left 1, down 3. graph of that quadratic diagram.
Those are horizontal.
If there was a horizontal stretch factor would be for the x. Yeah, for the x. Questions at all there? All right. Don't worry about it. Please, you try this one. I'm going to pause. Okay, there's the graph. Raise your hand if you got it. You know what you need to work on then. You can't get this quadratic. Right, check it out for a moment. You need to watch. Moving ahead to another type of function. Here's another graph. This one is much more difficult than anything you'll see. What type of function is this? Can anyone tell me what type? Yeah. Exponential function here. We do have an HK. Our HK is this in fact form right here. The 1 is the H. Okay, well, it's going to be the opposite of that, which is -1, comma, -4. So I'm going to put an X there. -1, -4. -1, -4. Do exponentials have a vertical asymptote or a horizontal asymptote? Logarithms have vertical asymptotes. Exponentials have horizontal asymptotes. Now, there we do have a parent. The parent function is y is equal to, does anyone know? 2 raised to the x. Okay, 2 raised to the x. All we have to do is plug in 0, 1, and -1. 2 to the 0, 1. 2 to the 1, 2. 2 to the -1, 1/2. The vertical stretch factor is up there in green. This right here is the vertical stretch factor. So it's going to be equal to -3. That -3 affects all the y's. So this is going to be -3 times 1 is -3. -3 times 2, -6. -3 times 1/2, -1. Is there a horizontal stretch factor? It's 2. You see the blue 2 up there? But the horizontal stretch factor is not 2. It is 1/2. Very good. That right there is the horizontal stretch factor, but it's always the reciprocal of it. So it's going to be 1/2. The 1/2 affects the x's. 1/2 times 0 is 0. 1/2 times 1, 1/2. 1/2 times -1, -1/2. Now, all you have to do is from the horizontal stretch, from the HK, plot those points. 0, -3. 1/2, comma, -6. 1/2, -6. 1, 2, 3, 4, 5, 6. And finally, -1/2, -1.5. It's going to look exactly like this. Questions at all about that? See how close we were? There it is. Don't worry about that. You can try this one. Be more realistic. Go for it. Also, please try to donate in the range zone right below your ground. All right, I want to see the hands. How many of you can do this correctly? You can do this correctly. All right, I like it. I like it. All right. Next. All right, hopefully maybe you can watch this. I have something up here that I'm not going to use on this one. What am I not going to use? I'm not going to use the parent function at all because I've got myself a rational function. Rational function means fraction form. What can you not have in the denominator? Or you asked me this before, what can you not have in the denominator? 0. So what you're going to do is you're going to find the vertical asymptote right. We don't need any of that. I'm going to get rid of it. We're going to find this vertical asymptote by setting the denominator equal to 0 and solving x equals 0. Here's your vertical asymptote. Go ahead and draw it in. Now there is a horizontal asymptote. Normally, if there wasn't a -2 horizontal asymptote, since the degree of the numerator is less than the degree of the denominator, it would normally be 0. But what does the -2 do? Brings it down to 2. So you've got a horizontal asymptote of x is equal to, y is equal to -2. Your goal now is to start substituting in. Pick one point to the right of the vertical asymptote, pick one point to the left. I'm going to pick 5. Y is equal to 3 all over 5 minus 4 minus 2. Y is equal to, this is just be 3 minus 2, 1. So I've got a point. It's going to be 5, 1 that I'm going to plot. Okay, 5. Hey, should I be plotting these points from a HK or should I plot them from the origin? From the origin. We're not using a parent. Very good. Next, how about I substitute in a 3? So let's go. Y is equal to 3 all over 3 minus 4 minus 2. This is going to be -3 minus 2 is -5. We're going to plot point 3. Did I do that correctly? Yes. So 3, comma, -5. So 3 comma -5 is right here. Now you can draw your branches of the hyperbola. Okay, domain. What can x not equal? X cannot equal 4. Very good. Range. What can y not equal? -2. There's your domain and range for that rational function. All right, moving ahead. Okay, for this logarithm, should I use a parent or should I not? Yes. All right, what I'm going to ask you to do, I want you to go ahead and graph both of these. Okay, for this particular log, we have a parent, which is y is equal to log base 2 of x. All right, now, keep in mind to rewrite a log in exponential form, it's 2 raised to the y is equal to x. So now we're going to substitute in for the y, so 0. 2 to the 0, 1. 2 to the 1, 2. 2 to the negative 1, 1 half. There's no vertical stretch. There's no horizontal stretch. You don't have to worry about it. But we do have a HK. Our HK at this point is going to be 3 comma 5. 3 comma 5, put an X there. And now, should it be a horizontal asymptote or vertical? Vertical. From the X, we're going to plot those points, 1, 0, 2, 1, and finally 1 half negative 1. Your graph should look like this. Domain. Domain is going to be X has to be greater than 3. Range, all reals. There's the graph of that one. Next logarithm. We have a bunch of things occurring here. It's a little bit more difficult. We have for parent movements. Here we go. First, for the parent, y equals log base 5 of x, or 5 raised to the y is equal to x. 5 raised to the 0, 1. To the first, 5. To the negative first, 1/5. Is there a vertical stretch factor? What is it? Negative 3. Remember, now let's do negative 3 times 0, 0. Negative 3 times 1, negative 3 times negative 1. It's a positive 3, sorry, positive 3. Now what we have is we have an HK. Our HK here is going to be 2, not 4. 2 of 4, put your X, vertical asymptote. Keep in mind we're going to go 1 and then 0. And then 5, negative 3. And then finally 1/5, positive 3. Domain. What should the domain be? X has to be greater than 2. Range. Y can be all reals. Next page. Okay, this is the square root. You can use the parent. The parent for a square root is just the square root of x. Nothing changes here. We can use a parent. It's pretty easy. Let's substitute in. Square root of 0, 0. Square root of, how about 1? 1. Square root of 4, 2. That's all you want to do right there. Now, is there a vertical stretch factor? It's equal to negative 3. So now, negative 3 times 0. Negative 3. Negative 3 times 1. 0. Sorry, 0. Negative 3 times 1. Negative 3. Negative 3 times 2. Negative 6. Do we have an HK? What's that HK? Negative 3, negative 5. So negative 3, negative 5 is right here. Is there a vertical or a horizontal asymptote for square roots? Some of you don't remember. Square roots look like this. there is no vertical or horizontal asymptote. So let's just start our movements. Let's first go with 0, 0. 0, 0, let's just write on our x. 1, negative 3. 1, down 3. There's the 1, negative 3. And then 4, negative 6. 4, 2, 3, 4, down 6. 6. And there is the graph. Why doesn't it continue, folks, in the other direction? Because you can take the square root of a negative and remain in the real numbers. Domain. X is going to be, look at the least value that x is going to be equal to. Negative 3. So it's going to be greater than or equal to negative 3. For the range. The range is going to be below negative 5. So y has to be less than or equal to negative 5. Okay. Next. Look at these 6 problems. Able to factor different sums of perfect cubes, folks. I don't know how this is going to work. You're going to have to remember these 2 formulas. You have to. Now, let's look at this first one. X cubed plus 125. Well, first, it's a binomial times a trinomial. Since it's starting with a plus here, we're going to use this plus one. So that's going to be plus minus plus. This is going to, what's the cubed root of x cubed? X plus, what's the cubed root of 125? 5. Now over here, we're going to get x squared. Then minus 5x. And finally, plus 25. And you could try to continue, but this is going to be, you've exhausted all your factors here. Y cubed minus 8, a binomial times a trinomial. Since it's a minus, we're going to use this one here. This is going to be y minus 2 times the quantity, y squared, plus, careful, plus 5, and then plus 4. This one here. Set it up. What's the cubed root of 64? 4. So we're going to have 4n and minus, what's the cubed root of 27? 3. Now, this one here, right there, is going to be a 4n squared. What's 4n? Quantity squared. 16n squared. Finally, right here, after the 16, we're going to do, this is going to be minus 12n. Oh, plus 12n, sorry. And then plus no. 9. Let's see how you have to work through this. Look in your book. You'll do a bunch of problems like this. Number 4 over here. Let's try this. Binomial times a trinomial. Cubed root of 27 is going to be 3t. Since it's a plus, look at the version. We're going plus minus plus after, so this is going to be plus. And then we have the cubed root of 343. 7. This one now will be 3t quantity squared, so it's going to be 9t squared. And notice up there it's going to be a minus 21t. And finally, plus 49. Guys, look at these a little bit here. In both of these, the The last term is always positive. Okay, and here's how I remember it. If it starts with a plus, then the next one has to be a plus. If it starts with a minus, the next one has to be a minus. You know the last one is always a plus, so this is the one that fluctuates. Does that make sense? So plus, plus, minus, plus. Here's minus, minus, oh, plus, plus, because the last one has to be a plus. So with that said, on this last one here, one on number 5, you better be careful. It is not set up automatically as a sum of perfect cubes. We must factor out the 2 first. So this is going to be w cubed plus 27. Now this is going to be 2. I'm going to bring that 2 down here. What's going to be inside here? W plus 3. Now, since this original one was a plus, we have plus, plus. Guess this next one is going to be a minus. Okay, so 3w squared minus 3w plus 9. Let's do one last one and call it a day. I'm going to factor out a GCF. What do you see as a GCF? Maybe a 5? We're going to end up with 8b cubed minus 625 divided by 5. 125. So this is going to be 5. We have a 2b. This is going to be a minus 5. First term here is going to be 4b squared plus 10b, careful, and then the last term is always positive, plus 25. And that's how you factor those folks.